I am Apparao Rao. I am a RA Bowen Endowed Professor in Physics and Astronomy, and I'm the founding director of the Clemson Nanomaterials Institute. So here at my lab, we basically work from ground up, starting with basic nanomaterials and refine their properties and translate those into useful devices. And my role for the VIPR-GS project is to try to do this for making better batteries that operate at elevated temperatures and also at some cold temperatures. So we are trying to expand the operating range of the batteries of interest to VIPR-GS.
My name is Morteza Sabet. I'm a research assistant professor in the Department of Automotive Engineering at Clemson University.
The solar and wind technologies have taken off very well, but what has not taken off equally well is storage technologies. So storage can be either in supercapacitors or batteries, and our focus area right now is in batteries, although previously we have also worked with supercapacitors. We are currently restricted to making only coin cells, which are like this button type batteries, but obviously we can't run vehicles on that. So we are trying to scale up to something we call a pouch cell, and I have an example of one of them right here. So this is a pouch cell in which there are multiple layers of active materials. They are prevented from shorting each other by separators. So this is one of the projects we are doing with an industrial partner, and we want to be able to deliver something like this for the VIPR-GS project.
We got a series of equipment that actually help us manufacture those pouches, but much faster, and also it enables us to scale up our coin cell batteries, because we do deal with new technologies every day. So whatever we make in the coin cell scale, we should be able to scale up and then go to the pouch level. So with this new center for pouch cell manufacturing, we will be able to just make those new technologies in larger scale and then go to the pouch cell level.
To go from this coin cell to the pouch type batteries, we need a lot of machineries, which is basically like set up a mini battery manufacturing line. And we are doing that at the Clemson Nanomaterials Institute with the help of SCRA, South Carolina Research Authority. So this institute is in their building, and they are helping us put up a dry lab so that the chemicals will behave better when we translate them into a pouch cell. So we will be having a dry lab with a relative humidity about 2% and a series of equipment that will help us go from start to finish, start with the raw materials all the way to making a pouch cell, something like this one. So that's where we are, and the goal is to make enough of these in a day. Right now we have the technology to make a pouch cell, but we are doing it by hand, and it takes us about one pouch cell a week, which is very difficult to then go to the next level, which is what we call the module. So this is a module. So there are 4 such pouch cells in a single module, and this is what the automotive industry really uses. So in future projects, that's what we want to go, right from the pouch cell all the way to a module. So right now the current project is focusing on the pouch cell, and then with additional support and additional technology, we should be able to go up to the module level. That's what our intention is to deliver for VIPR-GS project.
The performance evaluation from the pouch enables us to just establish some models with the help of other VIPR-GS researchers. So we will get those models, and those models will help us to design the battery pack and then know what charging protocol we have to apply on a battery pack. So we get a lot of useful information.
Overall, what we hope to do is to deliver not only pouch cells, which contain the materials that we prepare in this lab. We want to go from the pouch cell, put them into a module, and if we can make enough of these modules, actually have a deep orange project where we can electrify one of their vehicles. So this is going to be a long trajectory for us, but I think it is all doable given the support and the technology or the knowledge base that we have here.